Welcome back. Welcome to GCC. If this is your first semester here, we're happy to have you. Welcome to Calculus 2. As we've been distributing, we've got to make sure we have 4 things in front of us. They're listed over there on that sideboard. So if you're missing anything, let me know ASAP, and we'll make sure that you get a copy of everything that you need. So lots of little logistical stuff before we jump in and start doing some calculus together today. So the first thing is if you could find the document, it's one of the packets that says practice problems at the top. Looks like this right here, practice problems for Math 202. And you're going to look for number 13. I don't know what page it's on, but you'll have to turn the page. Looking for problem 13. Anybody find a page for us? Page 8. So go to page 8, you'll find 13. So 13 is supposed to look like I have on the board, but that's because I fixed it after I printed it. The F was missing on your copy. So it should say F of X. Everybody see it? Number 13, add that F there. That'll be the last mistake I make all semester. All right, so that's that one. Okay, my second mistake is here. On the syllabus, which looks like this, near the top of that very first page of the syllabus, it has my studio hours listed as Tuesday. I have changed them since I printed this, so cross that Tuesday slot off completely, and we're going to replace it with what's on the board over here. Friday, 11:45 to 12:45. Same column, I'll be in the studio, just a different hour than when I printed this a few weeks ago. Friday, 11:45 to 12:45. Okay, so I think we have all that we need to have. All right, great. So here is our calendar. It's going to look familiar to you if you took 201 here. It's on the last page of your syllabus, so you have it there. There's an extra column that we didn't have before, this practice problems thing. We'll talk about that in an upcoming class. But I do want to point out that project number 1 is officially assigned, and you have a copy of that. And I'll say that there are some differences between this semester and last semester, and one of them is are the projects. So what I want to pull up is this. So you remember at the end of 201, if you took it here last semester, the very last project, you reflected on what you had learned in the semester and what you thought of the layout of the course. And so I just wanted to let you know that Caitlin and I read those, and we have responded to some of them. So here's some things that are similar and then some differences between this class and 201. So some similar things, 3 tests, just like last semester, 5 take-home quizzes. I think we had 4 last semester, but the fact that their take-home is the same. 1 final exam, just like before. I will continue to make PDFs of smart notes and put them on Moodle regularly. I'm making a YouTube video right now. There are YouTube videos of the sample test problems. It's distributed a little bit differently, but we'll talk about that soon enough. Daily homework, daily reading, daily questions of the day, same as last semester. And then if we keep going here, I don't know if Caitlin had different grading options. Yes, so grading options where you'll tell me how you want me to weight your different assessments, and you'll give that to me in like a month's time. 3 packets, this is a quote from one of you. I thought the classes were structured very well. So the packets will have the same kind of structure as before. Daily summary, a very short demo where essentially I do a problem for you introducing new material, long group activity where you work with your neighbors, answers to all the group activity problems just like before, and then learning objectives. So all that's the same. So here's some stuff that's different. So last semester, the half hour before your calculus class was studio time, and that was a good opportunity for many of you to sit in the studio and finish up your math homework. Some of you are smiling because that was when you started your math homework, but in any event, it's not part of the course anymore. That said, the Math Studio is covered in the hour right before we meet every Monday, Wednesday, and Friday. So even though it's not like built in, I'm assuming most of you don't have a class between noon and 1, so if you could make it part of your routine to just be there right before our class, you might find that that's helpful to you. Okay, here's something different. Some sections in the packets include another group of problems that we're labeling even more practice/challenge problems. Those also have answers to them. You guys are kind of the guinea pigs here in that this is the first time this exists, so undoubtedly there are some errors in there. When you find them, let me know, and I'll let everybody know, and I'll fix them for next time. All right, big difference in terms of the projects this semester compared to last semester. So last semester there were 6 intense, quite long, quite involved projects that were due about a month after you got them. So this semester there are a couple more. There's 8 instead of 6, and then I think plus the one reflecting project. But these projects are much shorter. You'll have about a week to do them between when I hand them to you and when they're collected. So for example, that syllabus calendar there says that project number 1 is collected on February 4th, so Wednesday next week. But they are much shorter, like I said, so you don't need the full month that you had before. And where are we here? One of the quotes that you guys came up with last semester had this preference that it would be great if it was only 1 project assigned instead of 2 that we're supposed to be keeping track of simultaneously. So again, we've heard you and we've responded, so you won't ever have 2 projects that are both outstanding unless you're late on the one that you should have already turned in, okay? All right, another quote from one of you. I feel like this course has been reworked many times. Same thing is true for 202. Hopefully there won't be too many errors, but like I said, let me know when you find them. All right, just a couple of other quotes. Most of the time having the demo short was good. A little bit longer of a teacher-led demo. Honestly, like I'm reading these back to back, so it's hard to please everybody because you have people that are maybe sitting at the same table that have completely opposite opinions on the group activities and the demos. So my comment here was that if it's going to be a longer teacher-led demo, it has to come at the expense of something, and I was assuming it was at the expense of group time, and somebody else writes make the group activities a little longer. And so, like I said, I can't please everybody, but the flow should be quite similar to what you saw last semester. Somebody said 201 was a lot more intense than I had anticipated. I've got bad news for you regarding 202. It's time to change the anticipation, I guess. Change your expectations. This is a tough course. So typically there are 4 classes in the calculus sequence. You did Calc 1 last semester, many of you. Then there's this one, Calc 2. Calc 3 is basically Calc 1, but in higher dimensions. So instead of having just curves in 2 dimensions, you'll have solids and planes and things like that in 3 dimensions and higher. And then some schools call it Calc 4. We call it differential equations. Of those 4 very traditional calculus courses in sequence, I think number 2 is actually the hardest. It feels like it should get harder as you go on, but honestly, there are just some things in this class in particular that I think are just really, really challenging. So be prepared. Not trying to scare you, but trying to give you realistic expectations. Somebody mentioned, is it possible to have some review time for some of the homework problems? My answer is not between 1 and 2:10, which is when this class officially meets, but I'm always free before class. I'm always free after class. Oftentimes I'm free for a long time on either end. All right, so I'm happy to answer homework questions. I'm sure your neighbors will be too, but you shouldn't count on us spending our official 70 minutes together and looking at homework. Somebody else said, a very effective structure, especially while in groups, having Caitlin explain something you found difficult without having to interrupt the class to do so. So we'll do the same thing this semester. You've got the flags there, and we'll give it our best shot. Questions, comments? Okay. All right, so there are not project review days. Good question. So last semester, because of the intensity of those 6 projects, Caitlin and I decided we were going to just like stop everything, put everything else on the back burner in terms of the new material and give you an opportunity to work with each other and check in. Not to say that these 8 projects are easy, but they're not near as intense as those other ones. And so definitely want you guys to work with each other on those projects. It is not going to happen during class though. Good question. Other questions? Okay, so one other note and then we'll jump in. So one thing that's posted on Moodle is this Excel sheet. It's a, so I went through our list of classes. I did this a few semesters ago. And I went on Khan Academy. Any of you guys ever use that site, Khan Academy? So I went on Khan Academy and I just did a quick search to see if I could find videos that seemed relevant to the material that we covered. Now I didn't watch all of these videos. I just like went by the title of the video, or maybe I watched a few seconds of the video. So this is my best guess as to how to kind of match our material with his videos. So it's up on Moodle. If you are looking for another source of calculus material, this might be something to try out, right? Just let me know how it goes. Okay, so finally now we'll get to doing some math. So the biggest packet you have starts with this integrations formulas thing at the top. So we're going to flip all the way to page 12, and we'll come back and talk about the pages 1 through 11 at some point. But right now we start on page 12 with this review of differentiation. Okay, daily summary. Isaac, could you read daily summary? Thank you. Ryan, number 1. Go ahead. Okay, so let's move on to 2. Brendan. Okay, so there was a problem that we did at the start of Calculus 1, if you did it last semester, that had to do with dropping a ball off of the CN Tower in Canada. And just to be clear, this parabola-looking thing here is it's not the path of the ball. The ball is just going straight down. The bottom axis here is time, so we've got a certain number of seconds that are elapsing, and then the vertical axis is the height. The ball is just going straight down, but time is passing, so the graph kind of looks like it's going down and right. And what we were interested in finding was maybe the velocity, the instantaneous velocity at one moment in time, for example, 5 seconds into this ball's flight down to Earth, right? So we drop it, time 0. 5 seconds later, it's got a height of 327.5 feet or meters, whatever it is, but I want to know how fast it's going at that point. So finding instantaneous velocity was kind of one of the motivating things that we talked about at the very start of last semester, maybe second or third class. And so if we just take a look at this blue line that connects our fixed point here in red to this green point that we can move, I can't find instantaneous velocity immediately, but what can I find if I think about slope of that line segment? That's an average velocity, isn't it? The slope of that line right there will be average velocity, which makes sense because we know that velocity is distance over time, yes? Distance over time. So what distance does the ball travel going from the red point to the green point? Well, you just look at the change in the y coordinates, right? Just the change in heights, change in distance. And then how much time elapses? Well, you just look at the difference in the x coordinates or t's, right? So change in distance over change in time is exactly like change in y over change in x, which is a slope. And so the slope of that line right there, it looks like it's about negative 69.5 feet per second or meters per second, whatever it is. Okay, that's the average velocity going from between the red point and the green point. So if I wanted to get a better sense of the instantaneous velocity at red, I can take this varying point and move it which way? Let's move it closer to the red. So maybe I'll go to there somewhere. It's still an average velocity. This line still hits the curve in 2 different spots. And the average velocity there is about negative 54 feet per second. And so we spent time talking about this idea of limiting, right? I'd like to basically put the 2 points on top of each other. Up until that moment, this was called the secant line. But if I actually were somehow theoretically able to plop one on the other, it becomes a tangent line, which you guys studied over and over and over again last semester, right? And so the slope of that tangent line was our definition for instantaneous velocity. And it looks like it's about negative 49 feet per second in this example. Okay, so there's the picture that kind of motivated the definition. So here's our definition. We had a couple of definitions, but here's one of them. So f of x plus h minus f of x divided by, I'll write something extra and then I'll cross it off. X plus h minus x. So that should have the feel of a slope calculation, right? We can see the change in y over change in x in that fraction. Right, and so I said I wrote extra, right, you can cancel on the bottom. And so the real definition didn't write all that stuff out. It just had the h down there. And so the fixed point was at x, and then this plus h was saying move some arbitrary amount a little bit later in time maybe. And what I'd really like to do is send h to what number? Is to 0, right? Because h is how much time we're letting elapse. So we're just going to try to shrink that little time window down. So we talked about limits last semester. And so limit as h goes to 0. That's our full-fledged definition of the instantaneous velocity. And that was something that we called the derivative. And f prime of x was our notation for it. Okay, and then some interpretations of the derivative. Well, we just saw one. How did we interpret the derivative in that ball example? I'm gonna want one more word in the front of this word speed. Is it average? Instantaneous, right? It's not average anymore. Using that idea of limit, we were able to make it an instantaneous speed. Good. And you also spent time in your Calc 1 class talking about different applications of the derivative, and they all involved instantaneous something. Right? Could have been the rate at which your profits were changing as you made more of a product. Could be the rate the volume of a tree is changing as it gets taller. But all of these things were instantaneous rates of change. Okay, so now we'll actually get our hands a little bit dirty and start doing some calculations. So here, number 3, Kyle. Okay, thank you. So looking at the table in part I, we're looking for an estimate for f prime of 2. A couple of ways to do this. I know that my derivative has to look like this, right? It's a change in y over change in x. So what can we put on the top to give us a sense of the derivative at 2? What numbers can I throw in those parentheses? So wait, maybe 1.99? We're trying to get near 2, ultimately. Yeah, like if we could do 2 plus a small value and 2 minus a small value, that would be ideal. Unfortunately, I'm only giving you 3 points in this table. That's all you have to work with. So it's not going to be a very small window, but it's all we have. So for example, we could do what's happening at 3 and what's happening at 2, right? And then the same thing downstairs. And so we'll crunch the numbers here. How much is f of 3 from the table? 9 minus f of 2, 4. And so our estimate is 5. I picked between 2 and 3, but we could have made another choice just as well. Could have gone between 2 and 1. That would give you a different number, another estimate. Maybe you take both numbers and average them. There are a lot of ways to do it. Like I said, we're kind of hamstrung, right? You only have 3 points to work with. So this is as good as an answer as any. Let's try f prime of 2 looking at the picture. So now I'm giving you a lot more information. There's the graph of some function, and I want the derivative at 2. So I'm going to find the spot on the graph at x equals 2. It's right there. And how would I estimate the derivative at that point? Tangent line, right? You literally have to draw a tangent line and then do some calculations. So with a straight edge, if you have one, see if you can draw a tangent line. And once you've got that tangent line drawn, what are you going to calculate to estimate f prime of 2? Slope, right? Because you said last semester in chanting form, the derivative is the slope of the tangent line. Right? Derivative is the slope of the tangent line. So we estimate the slope, I like to estimate the slope by picking points that are far away from each other. So for example, I'll pick this guy up. Trying to pick nice points if I can. So maybe this guy right here for me looks like it's about 3,7, and then I'll pick another point. Maybe this one down here is 1, -1. Your tangent line will look different. The points you pick will look different. We're going to get 30 different answers to this problem, but they should all be reasonably close to each other, right? And so my answer, again, which could be quite different from your answer, is what are we doing here? So now I'm doing 7 minus -1 over 3 minus 1. 8 over 2 is 4. If you get 3, no problem. You get 5, no problem. If you get -1, that's a problem. Question there? Yes, you. Is it okay? No, 5 is fine. Right, there's a whole range of acceptable answers. Okay, but then we get down to number 3, which I'm guessing is the most comfortable way for you guys to find a derivative, is if I actually give you the function, the rule. F of x is x squared. Oh, super. Finally something I can grab onto, get the exact answer. So we'll find the derivative. What is f prime of x? 2x, right? So we've got all these derivative rules from last semester. That's the power rule. And then to find f prime of 2, what are we doing? Putting 2 in for the x. So we get 4. Now I got lucky that I happened to get 4 using the graph. That usually doesn't happen. So don't worry about it if your answers to these 3 problems are 3 different numbers. Okay, so on the next page begins the group activities. They are massive and long as you remember Calculus 1 and try to shake off the rust you may have accumulated over the winter break. Raise the flag if I can help.